Hello. Thank you so much for being here. My name is Alex, and I'm thrilled to see a full room here today, especially after all the announcements we've had in our keynotes earlier. There was lots of things to grab your attention, so thank you for coming here to this session. A little bit about myself before we get started. My name is Alex. I'm the product manager for Amazon Machine Learning, and I've been working in the machine learning space for quite a while. Before Amazon Machine Learning, I worked on some of the internal tooling at Amazon, which is used for machine learning by many of our businesses, and that Amazon Machine Learning itself is based on. And before that, I've worked on products that were recommendation system as a service and search engine space. But what I'm really excited about is building platforms for developers. And this is why I'm so excited to be here today to tell you about Amazon Machine Learning, which is our platform for developers to build machine learning models and applications quickly and easily. So what is this session about? What I would like to do is I would like to show you how machine learning technology can help you keep your customers happy and how easy it is to build a predictive application, a smart application that uses machine learning technology in the AWS cloud using several different AWS services. Now, for myself, the best way for me to learn anything is by following along an example, and a real example, not something very abstract. So in this session, I would like to show you why it's important to listen to social media streams, whether it's Twitter, Facebook, or even LinkedIn, or even emails, to find customers who may be using these streams to reach out to you because they need help, and how you can build an application which can connect your customer care representatives to these customers to ensure that they are happy and that their needs are addressed. I won't spend too much time talking about the social media technology per se. What I want to do is jump right in and show you how to build an application using a number of AWS services. I'll show you how to use Amazon Machine Learning, our easy-to-use machine learning service for developers. I will also show the use of Amazon Kinesis for real-time event processing, AWS Lambda for executing code without standing up or provisioning any servers, Amazon Simple Notification Service, or SNS, for easy, robust push notifications, and Amazon Mechanical Turk for annotating your data to enhance it prior to machine learning process. If you're not familiar with some of these services, don't worry about it. As we go along, I'll quickly describe what each one of them does. And I'll show you some code here. This will be a code-intensive session, but there is only so much code that you can get on a PowerPoint slide. So I want you to know that all the code I'll show you today is already available on GitHub. Here is a quick link to get it, and I'll show you the link again at the end of the session. So please follow along. You don't need to take photos of slides that look interesting. All the code is out there, and all the slides will be available after the end of the session as well. So our application, the application that I would like to show you how to build in this session is a smart application to search the Kinesis, to search the Twitter streams, ingest the tweets via Kinesis, process them with Lambda, use SNS to dispatch notifications, and to motivate it, to show you why it is that we should care about it. Let me show you a tweet. Here's a tweet. It's a real one. I didn't make it up. I grabbed it from Twitter. What do you think? Is this something that we in AWS should take a look at? Should we reach out to this customer and find out what's going on, help them troubleshoot their connectivity? Anybody? All right, hearing some nods. So yes, we should. Here's a customer who is reporting a possible service issue. We should look into that. Here's another example. It's a customer who is providing a feature suggestion for one of our product teams. And we should make sure that this gets looked at by someone, that this gets routed to the product team so they can consider it. Here's a third example. We don't like to see these tweets, but sometimes we do. Here's a customer who is angry, they're unhappy, things are not working the way they expect them to be working. We absolutely need to pay attention to tweets like these and to reach out to the customer and make it right. And here's a fourth example. It's a very detailed question from a customer. It needs to be routed to an expert who can take a look at it and answer the question. All four of these tweets that I've showed you are tweets for the AWS Cloud handle. For the duration of the session, just bear with me and pretend for a minute that it is your job to actually bear with the volume of all of these tweets coming in and find a way to route the tweets to the right place. So you might say, well, it doesn't seem like such a big deal. Why do we need machine learning for this? Isn't it just a matter of somebody keeping an eye on tweets aimed at AWS Cloud? And it turns out that the social media stream is very high volume. And most of the messages, in our experience, upwards of 80%, are not customer service actionable. These are just not customers who are tweeting at us because they need help with, of any kind or they have a problem. These are all kinds of conversations. I'll show you a few examples. Here's a customer who's making a joke. It's a good joke. I like it. Nothing for a customer service agent to do here. Here is a technical site publicizing a study they have done on how different AWS regions compare to each other. They've included AWS Cloud handle in their tweet, but there is nothing for a customer service agent to do here. Here's a third example. It's a conversation on tweet. It's a public conversation. AWS Cloud is tagged, or the handle is included. But there is nothing to do here. There is nothing for a customer service agent to do to kind of butt into that conversation and join it. And here is another example, and we love to see tweets like this. It's a happy and satisfied customer. There is nothing for a customer service agent to do here. So from our experience, we know that in the case of AWS Cloud, upwards of 80% of all tweets are of the second kind. They're tweets which are not actionable. And it can get pretty expensive and pretty time-consuming to pay somebody to look at all the tweets and just separate them into actionable and not actionable. So what I would like to show you, that's our motivation for this applications that I would like to show you how to build, is how to build a machine learning model and an application that uses this model to find tweets as they come in and classify them as actionable or not and do something with the actionable ones. Before I get into the application itself, for those who don't know about Amazon machine learning, I want to tell you about the product really quick in one slide. Amazon machine learning was announced and available for generally available in April. At the time, it was the newest addition to the AWS service family. Amazon machine learning is a product that makes it easy for developers to use machine learning service. The service is fully managed. There are no instances to stand up. There is nothing to manage. It's use it as you go along. It is based on some of the same robust and powerful machine learning technologies that we use within Amazon internally. It connects easily and quickly to data that is already stored in AWS Cloud, whether it's CSV files in S3, whether it is Redshift tables, or whether it's data that is stored in MySQL databases that are managed by Amazon RDS. And one of the key things we wanted to do with Amazon machine learning is to eliminate this gap that exists today between having a model and having an application that can actually use this model. For with most machine learning technology out there, productizing a model, deploying it so it can be used at scale, so it can be used with low latency, so it can be used at high throughput, that's hard work. Sometimes it's plain impossible. And we wanted to eliminate this gap completely. So with Amazon machine learning, the deployment process is very quick. It's one step, or actually, depending on how you use the model, sometimes there is no deployment step at all. It's just the model is always ready to be used and give you predictions back. All right, so here's the problem. Let's just, here's my quick formulation. I'll read through it again. Here is what we would like to do. We would like to instantly find new tweets that mention AWS Cloud, ingest and analyze each one to predict whether a customer service agent should act on it, and if so, sends a tweet to customer service agent. It's simple to put that sentence out here, but to build this application, to deploy it, to make it run robustly, it could be quite a bit of work. This is not simple. It's easy to maybe build something that works as a one-off, but to build it as something production ready, that is hard. So wouldn't it be great if there were a bunch of services we could use to build this application and make it production ready right away? Well, it turns out there are services that we can use. And let's just walk through this process again and look at what services we could make use of. To find new tweets mentioning AWS Cloud, we of course have to go to the Twitter API. Twitter is a authoritative source of tweets, so we can retrieve tweets from there. To ingest the tweets, we can use Amazon Kinesis, our framework for real-time processing. It's a real-time scalable data processing service. And we can grab these tweets and get them into AWS Cloud. Then we can use AWS Lambda, a managed compute service that allows you to run code in response to events without setting up or managing any compute infrastructure. We can use Lambda to decide whether each tweet is actionable or not. And the way we will decide is by consulting a machine learning model that is managed for us that's created by and managed for us by Amazon Machine Learning. And finally, we can take only the tweets that are customer service actionable, and we can send them to Amazon Simple Notification Service, which is a push notification service. And SNS can deliver these tweets through a protocol of our choice. It can send a push notification to an application. It can send an email. It can call an API. Lots of possibilities there. One way or another, we'll get SNS to route these actionable tweets to our customer service agents who can take an action on. So let's dive into it. Here is the plan for building this application. We'll start by deciding which machine learning strategy we'll utilize to approach the machine learning problem within, how to decide whether a tweet is customer service actionable or not. We will then prepare the data that is used to train machine learning models. We'll go ahead and create a machine learning model using Amazon Machine Learning. Then we'll write and configure the code for our application using the rest of the services that we just talked about. And finally, we'll try it out. We'll do a quick demo here. All right, what's our machine learning strategy? Picking the machine learning strategy is all about zeroing in on what is that question that we want answered. Machine learning is a technology that enables us to answer questions based on patterns that have been found in historical data about events that are happening now that have not happened in the past. So our question here is simple. We have a tweet. We want to know, is this tweet customer service actionable? Yes or no? Our data set will be text and metadata from past tweets mentioning AWS Cloud. And so the approach we'll take is to build what's called the binary classification model. A binary classification model in machine learning jargon is a model that answers a question that can be posed as a binary. Yes or no, 0 or 1, customer service actionable or not customer service actionable, and so on. And our model will return to us not just a yes or no answer. It will give us a confidence score that we can use to decide what to do with each tweet that has been scored by the model. All right, next step, prepare a data set. Well, we need tweets, and Twitter gives us a very convenient search API to find tweets that from the past that mentioned our company's handle, AWS Cloud in this case. So it's pretty simple. I'm showing Python code here. I'll show Python for the rest of this presentation just because it tends to be very concise. It fits best into a PowerPoint slide. But you can absolutely do it with any language and framework of your choosing. So here we import the Twitter module. We execute a search. We get some results. And we can go back and get older and older results. So there's good news and bad news. The good news is we can get tweets, and these tweets come to us in a well-structured, reasonably clean format. If you've ever dabbled in machine learning, you know that no data set is ever 100% clean or well-formed. But the data we get from Twitter is pretty good. It's definitely good enough for our use. The bad news is we need to know whether each of these tweets is customer service actionable or not. We need to label it and show examples of labeled tweets to the machine learning process, which is what will find patterns that connect tweet text and tweet metadata to whether it is actionable or not. Twitter doesn't tell us whether a tweet is customer service actionable or not. Twitter doesn't tell us that because they don't know. That is not a part of what Twitter does. So what we need to do is we need to annotate these tweets ourselves, these tweets from the past. So the labeling process is essentially the process of going through these tweets and for each one saying, is this tweet customer service actionable or not? How many do we need? It's really difficult to say. Different problems require different number of training data points. But let's say that we need a few thousand at first. So how can we do it? The simplest way is we just sit down and do it. We download the tweets, we put them into a spreadsheet, we go through a spreadsheet one by one, and for each one we say, is this tweet actionable, yes or no? We say 1 if it's actionable, 0 if it's not. Anybody in the audience ever do this? A few of you. Did you enjoy it? It's hard work. It is absolutely hard work. It's actually really fun for the first 10, 20, 50, 100, maybe a few hundred. But after that, it's just hard work and it takes a lot of time. And you start asking the question of, well, can't I just pay somebody to do this for me? Turns out you can. Amazon Mechanical Turk is a marketplace for tasks that require human intelligence. Just like this one. Here we have a task where we need to look at a tweet and decide, is it actionable or not, in absence of any models. Of course, we'll get to using machine learning model to make this decision for us in the future, but to bootstrap our task, we need real people to look at these tweets. So I want to show you what the process of actually using Mechanical Turk to create a task like this looks like. Once you log into Mechanical Turk, there are a number of templates you can use to quickly jumpstart creating what's in Mechanical Turk are called HITs, which is human interaction tasks. In this example, I chose the other category because I want to design my task completely from scratch, make it look exactly like I want to. We start off by configuring metadata about this task. This metadata helps workers on Mechanical Turk actually find tasks that they're interested in. So we configure the titles, the descriptions, the keywords. Then we move on and we decide what reward we want to offer per assignment. How much do we want to offer for each tweet being categorized? And then we want to decide also how many different people should look at each one of our tweets. We can say just one, and in that case, each tweet gets looked at exactly once. It works. The question is, how confident are we that we're going to get exactly the right label, exactly the right answer every time? If we're not so confident, we can have the task, each tweet looked at by several people, 3 in this example. And then we can decide what to do if the labels that come back don't agree with each other. If they agree with each other, great. We have consensus. 3 people looked at this tweet and all of them said it's actionable or it's not actionable. If they don't, we can do a voting scheme where we say, well, there are only 2 possibilities, so 2 must agree, and so we'll take the majority vote. We can go ahead and just sideline all the tweets that have generated disagreement and look at them manually. The choice is up to us. There's a few other metadata fields we can configure here, but then we jump right into the next screen, which is the place where we can design the task interface. So here is a page that I've designed in Mechanical Turk that is shown to a worker on Mechanical Turk. And I'm asking the workers to look at each tweet and actually categorize it into one of 5 categories. Is this customer making a request? Are they asking a question? Are they reporting a problem? Are they angry or unhappy? Or none of the above? It's a little taxonomy I made up. It may not be exactly the right taxonomy for you. But what I want to do is I want to gather granular data here. Instead of just asking, is it customer service actionable or not, I ask a question that's a little more granular. I can always convert from this 5-category taxonomy to a 2-category, actionable or not. But it's nice to have the extra data in case later on I actually want to build a model that not only decides, is this actionable, but also decides, well, what kind of action is necessary. Maybe I'll send it to different customer service agents based on that decision. So I'm collecting more data than I need immediately. It's not a bad practice in machine learning world. But this is what our task looks like. The worker on Mechanical Turk will see some examples of tweets that fit into each category. And then they will see the tweet text itself. They'll make a choice and go to the next one. Once I've designed my task, all I have to do is publish a batch of data that I want labeled, which can be accomplished by uploading, in this case, a CSV file containing tweet text. And then off we go. The task is submitted. It will be bid on. If I've offered enough of a reward, I'll get results back. Once the results come back, here are a few rows from the spreadsheet. What I can do with these results is, again, reduce the 5-category taxonomy I showed you into 0 or 1, and just take a look at them, sanity check them. So let's walk through these tweets one by one. Here is the first one. I don't think it's customer service actionable. There is nothing for customer service to do here. Moving on. Here is another one. That is definitely customer service actionable. Here is a customer who is asking a question. We need to connect with them and tell them and give them some ideas. Here is another tweet that is actionable. A customer service agent could find a good tutorial and let the customer know. Here is a fourth tweet, also actionable, request for some codes. And the fifth one, not actionable, calls out several sponsors of TechMemo, which AWS Cloud is one. So this is great. Now we have our data set. It's annotated. It's labeled. We can jump into using machine learning to actually build a machine learning model from this data set. The process we'll use is a 4-step process. Very little about this is specific to Amazon machine learning. It's a process that's fairly universal in machine learning world. We'll start by creating 2 data sources. And data sources are objects in Amazon machine learning that store metadata about the data sets. So they store the data location, they store the data format, they store the summary statistics about the data. But it's really important to note, data source objects in Amazon machine learning do not store a copy of your data. No copy is made. We connect to your data that's already residing as CSV files in S3 or as tables in Redshift or as tables in MySQL databases managed by RDS. And that is a authoritative data store. We only read that data to create models when you ask us to. So we create 2 data sources here, training and evaluation. The training data source will be used to create our model. The evaluation data source will point to data that is not used to create the model, but we will use the data to evaluate the model to decide whether the model is any good or not. And that is really the only fair way to know whether your machine learning model is performing well, is to test it by asking for predictions for data where you know the right answer, but the machine learning model training process has never seen these data points. It can't cheat just by memorizing them and giving you the right answers back. So that is the industry standard way to evaluate machine learning models, by splitting up the training and evaluation data. And I'll show you how to do that in just a couple of minutes. Once we have our training data sources, the next thing we'll do is create a machine learning model, which is just a simple and single API call. Then we'll evaluate the model. And finally, and this step is critically important, we will adjust the model to make sure that it aligns with your business objectives. And I'll do a little demo. I'll show you exactly what I mean by that. For the duration of this session today, I will show you how to use the API to do all this. But you absolutely can do all of this through the Amazon Machine Learning console. In fact, we'll dive into console a couple of times. But I'm using the API because we are building an application, an end-to-end application here. So I want to make sure that you can see how you can build these similar kinds of applications using a set of APIs that are available to you today. OK, so let's create our data sources. The first thing we need to do is to create the data schema, just to inform Amazon Machine Learning what is the schema of the data we're looking at. So in this case, the schema is just a simple JSON string. It specifies the data format. It specifies the list of all the attributes in our file. If you think of a spreadsheet or a table, the attributes are the columns of this table. And so for each attribute, we specify what its name is, so we can refer to it later. And also what its type is, whether that data is numeric, whether it's categorical, free text, or binary. And then we specify the names of special attributes. So here we have a field, if you look towards the bottom, called attribute name training label. That's our label. That is what we want the machine learning process to look at to decide what patterns in the rest of the attributes connect to this label. So near the top, we have a special field called target attribute name. We say it's training label. Now the system knows where to look for the label field. Once we have our schema defined, here are a few lines of code to show you how to create a training data source. We start off by creating a structure, a dictionary in this case, called dataspec. Dataspec is a pointer to the data. So we store the data location S3, the S3 URI, we store in the data location S3 field. We store the data schema, which we just created in the previous step, in the data schema location. And then we create a special attribute called data rearrangement. We're telling Amazon Machine Learning, go to this location, which has all of our data, and take 70% of that data, start with 0%, end with 70, and calls that the training data source. And we give this data source an ID, DS tweets train in this case. We give it a name, we specify data spec, and we set a flag called compute statistics equals true to tell Amazon Machine Learning to go and compute summary statistics on all that data. Next, we create an evaluation data source, and it looks remarkably similar. The only things I've changed here is I've told Amazon Machine Learning to use the last 30% of the data for creating evaluation. So we've split our data, 70% training, 30 evaluation. And of course, I gave it a different ID and a different human readable name. The rest is the same. So when we specify this compute statistics flag, what Amazon Machine Learning does is it goes and computes summary statistics on our data. And it's an excellent way to inspect the data, to find problems with the data you didn't know existed, to confirm our assumptions, to just learn something new. So what I want to do is I want to jump into the product, and I want to show you what that looks like, what kinds of things you can see. All right. So here I'm looking at my training data source that we just created a little earlier, DS tweets train. And right away, one thing we can do is click on the target visualization field. These are our target attributes. And what we see here is, as we suspected, most tweets are not actionable. That's why that attribute is 0. Out of the nearly 9,000 tweets here, we've labeled 6,500 or so are not actionable, and 1,184 are. But we don't have to stop at just looking at the visualization of the training label. In fact, we can go in and look at visualization at all the categorical attributes. And we can see for each one how well it's correlated to the target, how many unique values it has, what are the most frequent and least frequently used categories. We can sort by these and so on. And we can dive in a little deeper. We've built a lot of this functionality here to enable these very effortless dive-in experiences. So you don't have to go back to your data store to do a query separately if you just want to get a little more detail. So I'll click here on screen name attribute. So these are the screen names of tweets that mention AWS Cloud. As we might expect, it's a very long-tail distribution. There are very few Twitter users who make a lot of tweets at AWS Cloud. Most of them make very few. But there are a few, the top 10 Twitter handles that do make tweets at AWS Cloud are all here. So we can take a look at some of these tweets. Here I'm going to focus on Hans B001, that's a Twitter user. I can actually take a look at some sample data rows, some of the tweets mentioning AWS Cloud from my data set that have been made by this Twitter user. I can tell the UX what attribute of the data I want to look at. So here we're looking at 5 tweets that Hans B001 made that mention AWS Cloud. And one thing jumps out at me. Most of these tweets are retweets of other tweets, and they're actually fairly self-similar. This gives me an idea right away. I paid for all these tweets to get labeled. Maybe I should have taken a pre-processing step where I try to try to find duplicates or near duplicates in the stream of the training data and only pay to get one of them labeled. And that's a different story. We can absolutely do that. But these are some interesting insights that we can just get just by browsing through the data. And we can visualize all our attributes, categoric, numerical, and text. We can look at which attributes have missing values and how many. All of this is here just to help you browse through the data, get a little more confident with it before you go ahead with the machine learning process. So let's dive back into our presentation. Let's make a machine learning model. It is really simple to make a machine learning model. What I'm showing you here is the simplest and the default path. It's a single API call. We say create machine learning model. We give this model an ID. We give it a human-readable name. We specify what kind of a model it is. This is a binary classification model, so we say ML model type is binary. And then we give it the ID of the training data source, the data source that points to our training data. And that's all we have to do for Amazon Machine Learning to know where to find the data, how is the data formatted, where is it stored. It will make all of this happen just from this ID of the training data source. And this is a very minimal call. In this call, I don't specify which transformations to apply to the data. I don't specify any of the parameters. What happens when I don't specify these is defaults are applied, but these defaults are not just one set of defaults for everybody. The data transformations that are applied are actually based on your specific data set. That is one of the things, these suggested data transformations have been created when we computed the statistics on the training data. That's just one benefit you get from creating a training data source. So we can absolutely take a look at the suggested transformations, we call them recipes, and go back and alter them. But for this initial exploration, we just want to get a model quickly. So I'll just accept the defaults. Once I have my model, the next step is to evaluate it. And the evaluation step is really simple. It's, again, a single API call. We create our evaluation ID. We give it a name. We say which model we should use for our evaluation. And then we provide the ID of the evaluation data source, which is what enables Amazon Machine Learning to go, locate the data, find it, create predictions for all the data records in the evaluation data source, then look at the true value, which we get from the label, and compute some kind of a metric. And what I want to show you now is what you can do with an evaluation once you've created it, what value you get from that. So I'll hop over again to my console. Here I'm looking at an evaluation of my Twitter model. And right away, you can see that a metric has been computed here. This metric is AUC. AUC, if you're not familiar with it, is a metric that is very commonly used in machine learning world to evaluate specifically binary classification models, models that answer a yes or no question. And this metric is well designed to be robust in many different situations. It's a great metric. In common situations, it ranges between 0.5 and 1. 0.5 means our model is worthless. 0.5 means it's just guessing randomly. If you have a model that just randomly returns a guess, it would get a score of 0.5 or something near it. A score of 1 means our model is perfect. It got every single prediction right. And a score 1 should be an alert to you that something is very wrong with your evaluation data. Here we have a score of 0.85. For many machine learning models, for many tasks which machine learning is used to solve, it's a pretty good score. But really, it depends on the task. For some tasks, 0.5 is incredibly great. For other tasks, it's kind of low. We don't know universally, but for most tasks, that's considered pretty good. So what we have here is a one single number that tells us how good our model is. It doesn't tell us how good this model is at addressing the actual business problem we're trying to solve. But what we can do is we can adjust the score threshold, which is to say, when a model comes back to us, it gives us a number between 0 and 1. And that number is the probability of the tweet being customer service actionable here. So the question is, how do we take this probability and actually make a decision? Should we route this to a customer service agent or not? We do it by establishing a threshold. We say we'll find some degree of certainty that we care about, and anything above that, we will say that this is actionable. Anything below it is not actionable. So in this example, it's 0.5, which is equivalent of saying, if the model is at least 55% confident that this tweet is customer service actionable, let's go ahead and send it to customer service agent. Question is, how do you know what the right number is? I mean, 50% confidence sounds pretty good. 70% confidence sounds good. I don't know. Should I just pick a number out of the hat? I shouldn't. What I should do is I should consider what are the actual business impact of different kinds of decision machine learning model can make. So here we have a task which is binary. A tweet is either customer service actionable or not. And we have a model that makes a prediction that is binary. It predicts that the tweet is actionable, or it predicts that the tweet is not actionable. So we have 4 possible outcomes. We have true positives. The tweet was actionable and the model said it was actionable. Great. We have true negatives. The tweet was not actionable and the model said it wasn't actionable. Awesome. But then we have the mistakes. And all machine learning models make mistakes. It's important to know that, and it's important to know how to deal with it. We have false positives. So we have a tweet that was not actionable, but the model said, you know, using this threshold we've established, we actually think it is actionable. Then we have false negatives. We had a tweet that was actionable, but the model said, nah, never mind, not actionable. You don't need to look at it. So here's a poll to the audience. Which kind of mistake do you think is worse for this application? Well, I'm hearing a split opinion here. False positives and false negatives. I will posit to you that I think for this task, false negatives are much worse than false positives. A false positive means that we had a tweet that was not actionable and was sent to a customer service agent, and the agent had to look at it before making the determination that it actually was not actionable. So it's kind of bad. You know, we're wasting the agent's time. But so long as it's not an enormous number of these false positives, it's not too bad. A false negative is a customer, a real customer, who needed customer service assistance that we've ignored. The customer service agent has never seen the tweet. They didn't do anything about it. That's not good. So what I can do is I can actually explore different thresholds within my model and see how the number of false positives and false negatives change. So if you look here at the bottom of the screen, we have a rate of 6.6% false negative rate and 3.5% of false positive rate. And I'm saying I want to change this threshold. I'm willing to accept more false positives if it decreases my number of false negatives. So I can just drag that threshold slider around. And as I do so, you see that the false positive and false negative numbers are changing. And my false negative rate is decreasing. And it's not free, you know, it's not magic. I do get some more false positives by setting a threshold so low. But I think it's acceptable. It is this process that's so critically important to machine learning processes. Just not only having models, not only having one number evaluations of these models, but knowing what your business objectives are, knowing what the business costs of different kinds of mistakes are, and aligning your model to be sensitive to these costs, to injecting this information in here. So I'll go ahead and save this score threshold. And let's go back to our slides. We've talked about machine learning process quite a bit. Let's talk about the rest of the application. We have a model now we just need to use it. So as a quick reminder, here is our data flow. Tweets come in, Twitter API tells us when a tweet shows up. We ingest this tweet with Amazon Kinesis. We process it with Lambda. Lambda makes a call to Amazon Machine Learning to get a prediction. And based on the call, it will, based on the results, it will either route the tweet to SNS queue, or to SNS topic that will publish it to customer service queue, or it won't. So let's go ahead and set this up one step at a time. And I'll start with the Amazon Machine Learning piece. We already have our model. All we have to do now is to enable this model for real-time predictions, because that's what we want to do. We want to make the decision in real time. As a tweet appears, we want to decide, is it actionable or not? This is a single API call. Create real-time endpoint. I provide a model ID. And what happens now is this model, this endpoint URI is created. It's an endpoint to which you can send requests. And that is now stored and associated with a machine learning model. So at any time, I can issue the getML model API, and I get all kinds of metadata about my model, including the endpoint URI, if one has been created, and some metadata around this endpoint. So this particular endpoint is provisioned for 200 requests per second traffic. So I can handle 200 tweets per second continuously with this endpoint. And this is configurable up and down. It's a soft limit. That's the machine learning piece. Next, we'll create a Kinesis stream. We'll create a stream that is ready to receive the data as it comes in. A simple single API call here, create stream. We give the stream a name, and we configure its capacity by providing the number of capacity shards for the stream. Next, we'll go to Lambda and SNS. And the Lambda function here is the glue. It's our entire application is code within the Lambda function. And we have to do three things here. We have to actually write the code that processes and routes tweets, and it's very simple code. We have to configure the Lambda execution policy to specify what this Lambda function is allowed to do. That's our basic security step. And finally, we need to connect the Kinesis stream to the Lambda function. So anytime a tweet comes in through Kinesis, an event is generated, and our Lambda function is configured to respond to that event. So one thing at a time. First, let's start with the Lambda function. What I have here is not the entire code of Lambda functions. There is not a whole lot more, but it's more that will fit on the slide. What I'm showing you here are the globals and the function signatures. So for the globals, we configure what our endpoint URI is. I left it blank here. We configure a model ID. We configure the ARN of the SNS topic to which we'll push notifications. And then for each notification, we configure what its subject is and what the prefix of that notification is. So take a look at these two things, SNS message subject and SNS message prefix. Keep them in mind. We'll come back to them in just a little bit here. Next, we look at the function signatures. There are just 4 functions here. They're JavaScript functions. They're really simple. We have a function called process records. All it does really is take a record. We know it arrives base 64 encoded, so we need to decode it and to parse JSON. We have a function called call predict, which makes an API, which makes a real-time call to Amazon Machine Learning prediction interface and gets prediction. We have a function called update SNS that's called only when we have a tweet that's predicted as actionable. So that function actually pushes the tweet into the SNS topic. And then we have a function check real-time endpoint, which retrieves the endpoint URI and makes sure it's ready to use. Next, we'll configure Lambda execution policy. This might look like a handful. It actually is not. It's incredibly concise. I would like to walk you through this one step at a time, because it's really important to see how easy it is to make sure our Lambda code is secure to only be able to do the things we want to do and not anything more. So there are 4 parts to this. The first part is logs action. What we're doing here is we allow Lambda to create logs in Amazon CloudWatch for our Lambda function. The second part is us giving permission to our Lambda function to call only one API of Amazon SNS, and only for one particular resource. And all we're allowing this function to do is we're saying, yes, you can publish a tweet to this specific resource. You can do nothing more with SNS. That's all you get. The third piece is we allow this Lambda function to call only two APIs of Amazon Machine Learning. The predict API, which returns a prediction, and the getML model API, which returns model metadata. And we need that to grab the URI of the real-time endpoint. And that's all. And we scope it down to a specific region, to a specific account ID, to a specific model ID. This function can only be used for this one thing, for these two things and nothing more. And the last part of it is we give this function permissions to call several Kinesis APIs to read data from the stream. And again, we scope it down to a specific region, to a specific account ID, to a specific stream name, and absolutely nothing more. All right, we've done that. The very last step is to connect the Kinesis stream with the Lambda function. And we do that by calling a Lambda API called add-event-source. We say our event source is our Kinesis stream, which is located in this region, in this account ID, and has this name. We say which function name is to be executed in response to events that arrive through the stream, which is process tweets. And we provide the role ARN that contains the permission policy, the execution policy for this Lambda function. So it's pretty well scoped down now. Let's do a demo. I've told you about how all of this works, but I would like to show you. So here is a tweet. It's a tweet. It's relevant to AWS. But I'm going to say that this tweet is not customer service actionable. There's nothing for a customer service agent to do here. Here is the exact same tweet as a JSON blob. These are just key value pairs. These are the kind of information we get from Twitter API. So what I would like to do is I would like to call machine learning right now to find out whether this tweet is actionable or not. And to do that, I don't really need to write any code. I can just use the command line tools, the AWS command line tools to do it. So what I'll do is I'll say AWS machine learning predict. I'll provide predict endpoint, which is here for this specific model. I'll provide the ID of this machine learning model, and then I'll provide the actual record, which is the JSON blobs that we just looked at. And let's go ahead and do that. So I've pre-configured that. Here is our command line. It's exactly the same command line as I showed you before. It just has the big JSON blob now. And so I can hit enter. And this request is made now in real time. And response comes back. And here's our prediction. We say our predicted label is 0. It's not actionable. We get the actual prediction score. And if you recall, earlier we configured our model to say if the prediction score is greater than 0.1, if the model is at least 10% confident this tweet is customer service actionable, then say yes. But here, the model's confidence that this is actionable is very low. It's actually 1.2%. So we've said no. We've done the right thing here. So this is good, but so far we've only seen the machine learning process working independently. What I'd like to show you is all of this working together. So I'm just going to make some tweets. Let's see what happens. What I've done here is I've configured my SNS topic to find tweets, to take the notifications for tweets that are customer service actionable and deliver them into my inbox. I have an inbox here on Amazon Workmail, so I expect emails to show up whenever it is that an actionable tweet is present. So I'm going to hop in back here. I'm going to start a quick service that I use to drive it from my desktop. I'm going to come in here, and now I'm going to make 2 tweets. So here is one. That is not a tweet. Here's one. I just borrowed the content from another tweet we looked at earlier. I think this one is customer service actionable because it's a customer who is looking for advice on using S3 on Rails with Heroku. So I'm just going to go ahead and tweet it. And I'm going to make another tweet. And again, this is a tweet that one of our previous examples. It's a tweet which just mentions several sponsors of tech memes, of which AWS Cloud is one. So here are 2 tweets. I go back to my work mail. I hit refresh. And I only got 1 notification back. I'll hit refresh one more time to prove it to you. So I've issued 2 tweets. I expected only one of them to be customer service actionable. Let's see if it's the right one. So I can click here. Remember the message prefix and message subject that we configured earlier in the Lambda function? Here is our message subject. It's respond to tweet. And here is our message prefix. And but the URI here is now augmented. And this is done inside our Lambda function with the ID of the tweet. So I can go ahead and click it. And yes, success. Here is my customer service actionable tweet. It showed up in my inbox immediately, right as I needed it. So great. All right. So here's a recap. This is our application data flow end-to-end, from Twitter to Kinesis to Lambda to machine learning, and then conditionally to SNS. You might ask a question, well, wasn't this a whole lot of trouble? I mean, this was not a lot of work, but still 5 different services. And what I would like you to think about is we've done this once, but what we've done is we've created a pattern that generalizes to many different sources of your customer service feedback. We can look at Twitter data, we can look at Facebook data, we can look at email messages, we can look at product reviews. If your customers fax in forms to you and you scan these forms, we can look at those. The only thing that will change is the connection from the event source to our data ingestion via Kinesis and the model. We'll create different models because people use emails in a way that's very different from how they speak and how they post to Twitter or how they post to Facebook. So we need different models for different data sources. The rest is the same. All right, so what's next? Please try the service. It's available to everybody today. It's launched in US East and in Europe in Dublin. You can download the social media listening application code, all the codes that I showed you here, plus a sample data set from AWS GitHub account. So you can go to this bit.ly link, or you can go to AWS GitHub account and look for machine learning samples. And if you have questions, shoot me an email, get in touch. I would be happy to answer any questions. And I'll finish up with that. Thank you very much. Thank you for being here.